For this video, let's continue our discussion of average rate of change by looking at some word problems. So for these, we're just going to jump right in and kind of develop the strategy as we go. But in all of these problems, we're essentially going to be able to plot two different points. We can connect those points with a straight line, and the average rate of change over that interval is just the slope of that line. So Caleb went into a cave. The light intensity and in quintilla per square meter as a function of depth inside the cave, and that's in meters, is graphed. What is the approximate average rate at which the light intensity decreases as Caleb goes from a depth of 5 meters to a depth of 14 meters? So that right there is our key information. So let's familiarize ourselves with this curve here, this graph. We know that the horizontal axis, that's our depth, and the vertical axis, that is the light intensity. So it seems like as he goes further into the cave, there is much less light intensity. It's highest when he enters, and after what looks like 20 meters into the cave, it's at its lowest point. But we're wondering, what is the average rate at which it decreases between a depth of 5 meters and 14 meters? So let's plot those points. So here is 5, here is 14. We'll go up to the curve for each of these. And for this, you might have to do a bit of a rough approximation. Like this looks like halfway between these tick marks. So maybe at a depth of 5, we're at, let's say, 4250. And this will be an approximation. So we don't have to be too exact, but you want to get as close as you can. And at 14, it looks like maybe this is 1250, since again, it's pretty much between 1500 and 1000. So we've got our 2 points. Now, visually speaking, what's happening is we're going to draw a line between these 2 points. Let me try that once again. And the average rate of change is just the slope of this line. Now, remember, slope is the change in the y values divided by the change in the x values. Or as a formula, we have y2 minus y1 over x2 minus x1. So we're going to plug those in. We can call this x2 and y2. This would be x1 and y1. So let me write it up here. The slope of this line, this secant line, so we call it a secant because it crosses through 2 points. If it just touches the graph, that's what we call a tangent line. But the slope of this secant line that crosses through these 2 points we're concerned about will give us the average rate of change. And we just got to plug in y2 and y1. So we have 1250 for y2, and we're subtracting 4250 for y1. And then our x value is at 14, and our x1 is at 5. So we can simplify this. This is minus 3000 divided by 14 minus 5, which is 9. And if you plug this into the calculator, you get minus 333.3 repeating. And that's candelas per square meter per meter, right? Because we have meters down below and that odd units up top, candelas per square meter, that's the y values. And this is just an approximation. So at this point you can round it, and the closest one that it's to is this 330 candelas per square meter per meter. And the reason it's not exact is because it's not easy to tell what the y values are on the curve. You can only really approximate this. And also note that our slope is negative, but the question assumes that it's going to be negative because we're looking for the rate at which it decreases. So that's why in all of these there's no negative, because it's implied, because this is the rate it's going down.